Hello and welcome. My name is Mike Lee, and I'm a Senior Product Manager with Teledyne in the Teledyne Integrated Imaging Solutions Group. The group has been in business for over 25 years and specializes in cameras for industrial machine vision and multi-sensor devices. I'm here to talk to you about the importance of high-quality imaging for mobile mapping. One of the product lines that I manage is a spherical imaging system called Ladybug, comprised of both hardware and software, used predominantly for mobile mapping in the geospatial industry. In addition to resolution, I'd like to speak about additional factors critical to successful imaging in mobile mapping. I'm going to assume that many of you are familiar with the benefits of high resolution. Who doesn't love to see an image where you can make out details like the license plate on a vehicle or read signage even from quite a distance away? This is important for mobile mapping because the value of mobile mapping lies in its ability to capture a large amount of information in a short period of time and derive relevant, useful information for critical decision making. Now, if you will allow me, I'm going to take a step back and provide a simplified framework for what I mean by supporting critical decision making. Let's start with an example. Let's say that you're trying to choose a restaurant for dinner tonight. You pull out your smartphone, open up the mobile mapping application, and search for a restaurant. You might filter criteria like the review ratings or the price range. And here's what we often do to make a decision. We'll look at the list of restaurants and select the ones that look interesting. Maybe we'll check out the reviews and look at the photos. What does the food look like? What does the place look like? You can also click on the location of that restaurant to figure out where there's parking or public transit nearby. Do you remember the first time you were able to click on a 2D map and then view a panoramic street view? You could scroll around, look at the surroundings. It was amazing. That's the power of having image information that allows you to make decisions. In this case, you were choosing a restaurant to enjoy your evening. You incorporate the images and other information to choose a restaurant for you to enjoy. Now let's transition this into a mobile mapping context, where there's a camera system manufacturer who provides the device to a system seller. They integrate the camera into a mobile mapping system for a service provider who plans the image acquisition missions, captures the data, and processes it to extract meaningful information. This information is intended for use by the decision maker. That decision maker may never actually look at the raw data or other sensor data. What they want to know is, with their operating budget, which roads need to be repaved this year. Or if they have assets like utility poles that are reaching the end of their life, can they determine which ones are showing signs of corrosion and need to be replaced immediately? So let me highlight one of the most important factors that is critical in this process: image quality. I think you are familiar with this, but I'll touch upon it briefly. Remember, it's about deriving the relevant information to make that critical decision. That's what you need to think about in terms of image quality beyond just resolution. For consideration is, can the camera system provide high quality images that enable the service provider to extract relevant information for the decision maker? Today, it's not just a human operator in the process. The value of mobile mapping lies in processing a large volume of data and deriving relevant information in a short period of time. It's likely going to be a computer vision software that performs the information extraction process. The computer vision algorithm is quantitative, objective, and precise. Aspects of image quality, such as wide dynamic range, allow you to see details in both the darker and brighter portions of the scene. This enables algorithms to segment the scene into different parts with a high level of detail. Accurate color information, along with texture, improves the confidence level during classification and allows you to classify each segment into an object category. Sharpness is also important because it enables optical character recognition algorithms to pick out alphanumeric characters on an asset or object detected in the scene. Pull out that identifier and tag it with that object. All of these elements, image quality, dynamic range, color accuracy, and image sharpness are highly important when it comes to mobile mapping. A second important consideration for the imaging system is its inherent geometric modeling and spatial accuracy. These are important when processing the data captured by the camera because you want to know where something is when you see it in an image. Another reason is that there may be an intention to register image data with other sensor data. For example, if there's laser point cloud data captured at the same time as images, you want to apply the appropriate color value to each 3D point. The geometric model of the camera, known as the camera intrinsics, describes the relationship within a camera between the sensor and lens. One of the important aspects to recognize is that all lenses have distortion, and it's important that for spatial accuracy, the model accounts for this distortion. Let me use a real-world example. Many of you may have 20/20 vision, but some, like me, wear corrective lenses. When you visit your optometrist, they check how well your eyes can focus on an object. Even if they adjust the magnification for you to see clearly in the center, the surrounding area may not be fully in focus. This is called astigmatism, where different areas of your lens are not perfectly round. Your optometrist can account for this and prescribe corrective lenses. Similarly, the geometric model for your camera can account for lens distortion and correct it, allowing for high spatial accuracy. Spatial accuracy refers to how close the representation of an object in an image is to its actual location. For example, if you were standing a couple meters away from me and want to see the color of the button on my shirt, you need to consider the degree of spatial accuracy. Is it on the order of magnitude of centimeters or millimeters? If you have laser scan data with high resolution and spatial accuracy in the millimeter range, you'll want your image data to be on the same order of magnitude to register that data accurately, which requires spatial accuracy. A third point that I want to share with you, which is really critical and enhances high resolution image content, is timing. Specifically in mobile mapping, it's about trigger timing, typically initiated by an external source. Why does this matter? You could run the imaging system in what we call free running mode, capturing at a fixed number of frames per second. This makes sense for applications like video, where you need a particular frame rate for smooth playback. However, in mobile mapping, there's typically a specification for optimized coverage along the transportation corridor that you're capturing data for. You want a specific distance between frames to ensure overlapping images. This helps optimize storage consumption and maximize the utility of processing resources and the time needed to turn the project around for the mobile mapping mission. Being able to use an external device, such as a distance measuring instrument, to initiate triggering is optimal for data capture. Now you're optimizing the data being captured for mission coverage while minimizing both the amount of storage consumed and the post-processing time and resources used. Another consideration is the fact that many other instruments make up a mobile mapping system. For example, you'll have a GPS or positioning system that provides both a timestamp and current location. The location is critical for determining where an object is in the image, as we discussed earlier with spatial accuracy. The timestamp is also critical because when the trigger takes place, you need to know the state of all other sensors in the mapping system at that time. These sensors could include ground penetrating radar, thermal imaging cameras, or laser scanners. Knowing the time and location when triggering takes place allows for geospatial data registration. For example, you can now use the 3D position of a point in a point cloud and look up the color value as seen by the camera at that instance in time. The fusion of geospatial data often enables further information to be derived that could not be done from the individual dataset. That's the value and why timing is so critical. There are a few more factors that I would like to highlight, particularly if you're considering the purchase of the imaging subsystem for a mobile mapping system. How long has the manufacturer been in the industry? What reputation do they have with others in the ecosystem? If you buy multiple systems, are they consistent in both quality and performance? Secondly, how well designed is the product for the rigors of mobile mapping? Varying weather conditions in temperature, humidity, shock and vibration can affect operations. Are they field proven? Thirdly, does the manufacturer stand behind the product with both multi-year warranty and responsive, knowledgeable support? These are all important considerations for the success of your imaging and mobile mapping system. Finally, I want to share a closing thought. We are in an era where we have seen exponential processing advancements in our lifetime. This has driven down the cost per unit of compute for all of us. We've seen the ability for devices to capture more data, more pixels, and more points per second for mapping applications, which is hugely beneficial to us and our society. Over the last several decades, this has allowed an expansion in mobile mapping applications. 18 years ago, Google introduced Street View. Today, mobile mapping includes scene segmentation for engineering surveys, asset management, pavement condition assessment, and urban forest management. The applications keep expanding, and it's astounding what this processing power has enabled. It has also allowed the tremendous advances we are seeing in the data analysis and information extraction portion of the value chain. Graphics processing units and neural processing units are giving rise to algorithms that process even larger volumes of data with increased levels of output and higher levels of confidence, for example, in the classification of objects using AI and machine learning techniques. These advancements are hugely beneficial, and as impressive as they have been, we are only at the beginning of these capabilities. However, what's important to realize is that as advanced as these downstream methodologies are in producing results, it's critical to recognize that acquiring high-resolution image data at the utmost quality with a high degree of spatial accuracy and precise trigger timing enables optimal results for critical business decision making. Well, this brings the presentation portion of our webinar to a close. My name is Mike Lee, and I'm a Senior Product Manager at Teledyne. If you would like to contact us, please have a look at the emails and phone numbers on screen associated with the region that you are located. I will now pass this back to our host and moderator.